Hello, welcome to the ALCTS webinar, Linked Data and Annotations, What We Stand to Gain. I'm Matt Montgomery from the College of San Mateo. I am a member of the ALCTS Continuing Education Committee, and I will be your host for today's webinar. Our presenter today is Joyce Bell. Joyce is the head of cataloging and metadata services at Princeton University Library. She retains a commitment to her first library position as an Arabic cataloger by ongoing involvement with the Middle Eastern Libraries Association and current membership on the Asian and African Materials section of ALA's Committee on Cataloging. Joyce has been leading Princeton's participation in the Linked Data for Production project with talented and dedicated group of staff. There are a few things to keep in mind for today's presentation. All attendees are muted. If you have a question for Joyce, please type it into the question box on your screen, and she will answer them at the end of the presentation. Our software does not have interactive chat capabilities. You may use the ALCTS hashtag if you wish to use Twitter to comment on today's webinar. The hashtag is ALCTSCE. We do not monitor the Twitter feed, so please use the question box to submit questions and comments. This webinar is being recorded, and you will receive an email with links to the recording and presentation slides. And now here's Joyce. There will be a slight delay as we change presenters.
Welcome, everyone. I'm very excited coming from snowy Princeton today to use this opportunity to round off the last 2 years of intensive learning, discussion, experimentation, and a lot more discussion to talk to you about Princeton's Linked Data project. Although several of our team have talked about our project before, this is the first time we can look at the results and consider what we stand to gain from a different encoding method for our data. I am the spokeswoman for our project today, but as always with endeavors of this kind, it takes a village. My deep and abiding appreciation goes to the members of my local team, in particular my original co-conspirators Jennifer Baxmeyer, Peter Green, and Tim Thompson. Without their enthusiasm and commitment, we wouldn't have attempted a project so far out of our normal activities. You might be wondering why this original group of 4 is pictured at an angle. We had just spent 4 full days discussing linked data at Stanford, and we were no longer able to stand upright. Turnover of staff definitely played a part in this project, as did competing local needs. One of our original team members, Tim Thompson, demonstrated more interest in and aptitude for the ontology work. When he left us for Yale, our intent to participate in the overall LD4P ontology extension group really fell apart. Similarly, a massive undertaking to reorganize and move the library's rare books material into newly renovated space meant that we were unable to add our rare books colleague, Regina Heberlein, to our team until somewhat later in the project. Our linked data project was done in connection with a larger collaborative. Along with 5 other institutions, Princeton is a partner in the Mellon-funded Linked Data for Production, or LD4P, collaboration, which is exploring linked data and Bibframe as a future for library bibliographic data. With Columbia, Stanford, Cornell, the Library of Congress, and Harvard, we have spent the last 2 years looking at and discussing workflows, ontology, and standards. Princeton committed to a specific local project as part of our work in this collaborative, as did each of the other partners. LD4P was originally intended to end at the end of this month, but the grant was extended to the end of June. So as a result, right now is when the various local projects are being completed, and the group's final in-person meeting will take place in May. More information on LD4P can be found on the group's DuraSpace website, which you should be able to find by searching LD4P DuraSpace. Princeton's local project centers on the library of Algerian-born French philosopher Jacques Derrida. In March of 2016, Princeton acquired Derrida's personal library, which had been kept intact by his family since his death in 2004. His collection covered large portions of his home, with materials stored on all 4 walls of his studio, snaking around through the living room and even up into his attic. The collection consists of nearly 19,000 books and other items. Almost 6,000 of them were annotated by Derrida himself, and 6,770 were presentation copies with personal inscriptions to Derrida. It is these presentation copies and these personal inscriptions that were the focus of our project. Our project involves Bibframe encoding for the traditional MARC data and special encoding for the presentation annotations. The focus today is largely on the annotation portion of our data, so I won't be directly discussing Bibframe. You can see from these examples that the dedications are often more than a simple "to Jacques from X." There is the charming example where Catherine has turned the title into a cat in a play on her name. The top central example is to both Jacques and his wife and mentions a meeting in Paris. There are several inscriptions that mention people, events, or the title of works. We chose to work on the presentation copies specifically because of these internal references. If inscriptions like these are mentioned in detail in a MARC record, they would be likely to appear as a block of text in a note along the lines shown here. The data is available to the user for viewing and keyword searching. Our goal was to identify the people, places, and events in the inscriptions and provide identifiers and use standard coding for dates so that researchers could make use of this data to look at Derrida's intellectual and social network. There are a number of digital humanities type projects which use data to explore networks of influence. Connect Vermeer, for example, is an international collaboration which has used linked data to make connections between Dutch genre painters of the 17th century. Linked Jazz is another project which mined oral history transcripts to map the network of relationships and influences between jazz musicians. The web pages for these projects mention years spent on gathering and managing the data, something that we have also heard from a number of scholars we've spoken to who are working on research into networks of exchange, whether or not they are using linked data. They still are dealing with the data. As librarians investigating alternatives to MARC in the form of more structured data, I believe we should also be carefully looking into making routine data gathering as efficient as possible, reusing data wherever we can, so that we can shift more of our focus and effort into providing deeper analysis in selected areas. Maybe we can make it easier for scholars to get their research underway when they're looking at exploring connections by providing some preliminary data in a way that allows them to easily query it, harvest it, and connect it to related pieces of information pertinent to their study. When I'm trying to explain why we would want to consider linked data, I usually go with an octopus metaphor, with tentacles linking our data more widely and in twisty, unexpected directions, and I end up waving my arms around in a dangerous fashion, which I'm actually doing right now. Since you can't see my octopus imitation, I provided a sedate Derrida quote. Derrida was not proposing to proceed along the lines of a linear order of reasons, and we won't either. What has appealed to me from the beginning is the potential for providing a network for a researcher to explore on their own, rather than providing set pathways through the data, which is what we do in traditional catalogs, where we provide structured access for specific data like titles, subjects, language, and format, leaving everything we don't specifically cover only available through keyword searching. A greater amount of structured data, coupled with the ability to make use of information from multiple sources, extends our cataloging from just a finding aid into a resource for research. Early on in the project, we met with a professor who was interested in Derrida's library, and from her we gathered some questions of interest from a research point of view. Derrida was a major influence on a group of philosophers and theorists referred to as the Yale School of Deconstruction. So what can we glean about his relationship with the other members based on these inscriptions? There were some real surprises in Derrida's library. In addition to several novels featuring vampires, there were some presentation volumes on Judaism. Derrida is not known for scholarship in this area, so who was sending him this material? Our scholar gave this as an example of the desire to explore networks of exchange that aren't otherwise evident. This desire to explore the unexpected supports the notion of providing data in a way that allows scholars to use the data to meet their own needs, rather than assuming our prepackaged searching will be sufficient. What other information can we find out from the dedications and about the dedicators? Well, once we can list them, we can explore their nationalities, philosophical schools, area of activities, and dates. Once we had decided on the Derrida presentation volumes for our project, we set about selecting the material for our data set. We decided to aim for 500 presentation volumes out of the thousands from Derrida's library. Since we knew that we would be transcribing and making public the text of the inscriptions, we made an effort to select as many dedicators as we could find who were already deceased. Naturally, we referred to them as our dedicators. Looking for death dates during the selection process meant that we began grabbing identifiers early on. It turns out that French philosophers are a hardy lot. It was astonishing how many of Derrida's contemporaries are still out there deconstructing things. Our bibliographic data, we plan to use Bibframe, but that didn't have structure that was suitable for us to encode the dedications. Early on, we looked around to see what was available that could be reused, and we created some sample annotation encodings using web annotation, which is the W3C standard. Confident that with that we had a basis that could work, we got started by digitizing the title pages and dedication pages of our sample set. And then we decided how to handle the transcriptions. Because we were dealing with informal handwritten inscriptions, mostly in French, we decided to use a double-blind transcription method followed by a reconciliation so that we were trying to get the cleanest data that we could. We hired 2 French-speaking students who each transcribed all of the dedications separately. Team member Peter Green put together a Microsoft Access form which allowed the students to view the images while they were transcribing. These separate transcriptions were then reconciled using the compare tool in the Oxygen XML editor to identify the points of difference between the 2 transcriptions. Transcription took roughly 40 hours for each of the 2 students and an additional 10 hours for the reconciliation. Running somewhat concurrently to the transcription work, we had a group of catalogers identifying existing copy for the publications and looking for identifiers for the dedicators who hadn't been identified during the selection phase. This last is an area where we might attempt to use name entity recognition software now, but we weren't set up to use it at that time. When the available bibliographic records were discovered, we ran a script over the records which added URIs for the names and subjects. Finally, we gathered a number of catalogers together to encode the annotations. We did all of this encoding within a single week. We started with a group training session where we went over the procedure, and we had each person create 5 annotations for our core group to review and provide feedback. Later in the week, we asked the participants to return during one of 2 open sessions to encode the remainder of their assigned annotations. Altogether, this work took in the neighborhood of 50 hours. Mapped out, this is what our process would look like. The collection is described in an EAD finding aid, which lists the individual titles and authors, but it doesn't provide full bibliographic data at the item level. We planned a stream of bibliographic records converted into Bibframe, as shown on the top half of the slide. Although we originally expected that we were going to be using a combination of existing records and new cataloging created directly in Bibframe using an editor, we ultimately ended up with all of the traditional cataloging data being converted from MARC. We did this because the Bibframe editor development coming out of the related LD4L Labs project wasn't sufficiently developed to be usable for us to meet our own internal timeline. And as mentioned, we did run all of the MARC through a script to pre-populate identifiers for names and subjects before the conversion. Our second stream across the bottom of the slide related to the inscriptions. Using images, we would transcribe them separately, reconcile them, encode them, and then the two data sets would be merged together. This all seems quite simple, right? Naturally, once we got into the project, it wasn't quite as straightforward as we had planned. Our actual process had some false starts, some extra return loops, and definitely some pain points. We had some image errors, and there were a few inscriptions we ended up rejecting because they were really, really hard to read. Some of the titles we couldn't catalog without pulling the material out of the rare books vault for a second time, the first time being when we did the digitization. So we ended up ultimately settling for a database with 450 objects that had the full set of annotation and bibliographic data. The model that we looked at in the beginning, web annotation, is the one that we ended up using. The LD4P group has put a lot of effort into Bibframe ontology extensions to cover issues for rare books, music, and other areas. As I mentioned earlier, however, Princeton's involvement in this work fell off when we had some staff turnover. So we really didn't consider using the LD4P work, largely because we were out of touch with it. But also, we had already investigated the W3C model and how it could apply to our material. And also, very importantly, we had a tool that was already partially developed from our preliminary work, which we could use with some additional development, rather than investigating a new data model and starting over from designing a new tool from scratch. So we used the web annotation model. We did have a few local properties that we put on top of the model. The basic model is rather simple. Somebody wants to say something about a web resource. What they want to say is the body. What they are saying it about is the target. Creating this relationship is the annotation. The model is not an ideal fit for our material since it's designed for an online comment on an online resource. And also because at Princeton, we are the ones who are making the annotations, but we aren't the originators of the comments, the original comments that were made. Two of the features important to our data beyond the body and target are the motivation and the text quote selector. The model allows for specifying a motivation or reason for creating the annotation, and it allows specifying a purpose for including the textual body. And we use both a motivation and a purpose in all of our annotations. The text quote selector is another feature of the model that we're using in this project. This allows us to pinpoint the specific portion of the body's text that represents the dedicator's name or what the text that we're tagging. Supplying this coding enables some functionality we'll have a chance to take a look at later. An extended view of the model relating specifically to our situation shows a little more detail in how we're coding the body and target. Each of our 450 objects has at least 3 annotations. The base annotation, which is really what we're looking at here, has Princeton University as the creator and the motivation describing. The body is the text of the dedication, and that has a purpose of inscribing. And the target has a link to the digitized page with the dedication as a source. Oh no, I'm sorry, let's see. Inscribing, the target has a link to the digitized page with the dedication as a source, and their scope is the item. This is where the annotation data gets linked into the Bibframe structure. Since the annotation is copy-specific data, it's linked in at the item level. Other annotations which are present have the motivation of identifying. The body's purpose is tagging, and the source is the text of the dedication. The target source is the same, the text of the dedication, but this is where the text quote selector comes in. It's used to pinpoint a portion of the dedication. And we have added an OWL same as relationship here to the VIAF identifier. Each object has several annotations in this format. There's one for Derrida and one for the dedicator. And there are sometimes additional annotations when other people are mentioned in the dedications. I won't dwell on behind the scenes too long, but the next few slides are going to show some pieces of our resulting encoding. Reading this screen from the top, in coding dedication 121, we have annotation 1, created by Princeton's LD4P group, in order to inscribe an annotation. The annotation's body is body 1, which is the text is provided in another spot. The target is an unspecified page of dedication 121, and it relates to the bibliographic data of 2089173, which is the bibliographic ID number from our Voyager system. Here is the bit of coding that relates to that particular item and hooks it into the Bibframe model. This time, I'm reading from the bottom up. The item relates to a specific instance, which in turn relates to a specific work. The local work identifier is connected with an OWL same as relationship to the identifier for OCLC's work data. Finally, this part of the coding shows an annotation created by Princeton's LD4P group to tag dedication 2, and it shows the text quote selector. With OA as the prefix for open annotation, the OA exact text shows that we are tagging the text string Aragon, who is identified with an OWL same as relationship to a VIAF ID. The OA prefix and OA suffix text include the characters immediately surrounding Aragon's name so that a computer can pinpoint the text within the overall text string. The editor that we used simply grabbed a set number of characters on either side of the selected text in order to populate the prefix and suffix elements. The web annotation model doesn't cover everything that we wanted in our model, so we made up some classes and properties to better suit our particular data set. I don't yet feel that I have a really good understanding of what the implications are of doing this within the larger semantic web. Within our data, extending the model can help us navigate more precisely, but what impact this has when others use our data set or when we connect it to other sources, that's the area where I'm a little bit uncertain about. Since we have begun working on queries against our data, we have been discovering other places in the model where further localizations might be beneficial. And a key point is the ability to distinguish between the dedicator and other people who are mentioned in the dedications. So one possibility might have been if we added a new property, is dedicator. Something like that would allow us to zero in on creators of the original dedications. To proceed with the coding of the annotations, we needed a special tool. Tim Thompson built a prototype of an annotation editor prior to the project as a proof of concept, and Peter Green further developed this later on in the project into the tool which was used by a group of catalogers to code the 450 annotations. I am going to flip over to a little video and walk you through how it works. Peter built, as we go over to it, Peter built in some links to our documentation, our working file where we assigned 50 annotations to each project cataloger, links to the data models, some examples, and other useful links. Our procedure was pretty straightforward, relatively short, and it followed steps that were built into the tool. Catalogers would open an annotation, tag entities in the text, do some manual editing, and then check and save the data. The first step is to call up an inscription. The cataloger selects one of their assigned objects, retrieves the transcribed dedication, which comes with RDF data already created following a template. The editor provides some additional links related to the specific inscription. There is also a link to the images, allowing the cataloger to double-check the dedication or the bibliographic data as needed. The editor has the reconciled dedication text and templated data, which already connects the dedication to Bibframe item work and instance. As tagging proceeds, additional sections will be added at the end of the template. Peter has used GraphViz, a graph visualization software, to generate a graph of the data. At this stage, the graph shows the single annotation containing the data created by the template. To complete the encoding, catalogers highlight each name in the annotation. The tool records the data highlighted and the text immediately before and after, and creates a new section of coding. And this one mentions Marguerite, his wife, so that's a second annotation that will be added. When the dedicator is selected, there's an extra box that's checked so that the identifier previously captured could be inserted into the coding for that person's name. A final step, once all of the names have been marked, is to search for the word check in the template. Doing so brings up a few places where we need to manually edit the data, coding a date if present, changing the language when appropriate, and enabling the line which references Marguerite Derrida if the dedication includes her were done manually. When everything looks okay, the cataloger can view the updated graph if desired. You can see our graph is a lot more complicated now with the 3 new annotations that we added. We can track pathways through the data. We can go over and take a look at our dedicator. Roger was his exact name. And we can trace back through the connections to see how it relates him to his VIAF identifier. Catalogers marked the spreadsheet when an object was complete. And we had a line where they were able to add notes. Like, this is fun, although no one actually wrote that. Use of the text quote selector allows us in an interface to highlight the representation of the names and link them to their VIAF identifiers, as you can see in this sort of preliminary system that Peter set up for us. And the dedicator's full name appears because we have the VIAF identifier. Although this presentation is focused heavily on the annotation aspect of the project, I wanted to give a general idea of the Bibframe aspect. Since we ended up using only data converted from MARC for our bibliographic data, Peter, once catalogers had created or identified all the records for our sample, Peter Green took over. We had to gather all of the bibliographic records, either from our local database or from OCLC. We harvested OCLC's work IDs, and we converted all of this data into Bibframe. Our local records had already been enhanced with URIs, so we needed to do the same for the records from OCLC. Then we had to gather the annotation data and put everything into a triple store. A number of locally created scripts were used during the project to perform various of the steps just mentioned. We also used a converter from the Library of Congress for converting the MARC records into Bibframe. We plan to make our scripts publicly available by the end of the grant in June, although some of them are really very specific to our situation and won't be of particular use. If anyone wants more details about our technical setup or the scripting used in our project, I would recommend that you contact Peter Green. As we saw very briefly at the end of the video, we do have a very, very preliminary interface. This wasn't intended as part of our project. Nonetheless, Peter has been experimenting with SPARQL, which is a version of the open source Blacklight software that uses an RDF triple store as its source. This interface serves as a proof of concept to show that the linked data can be presented to users with the same type of searching and faceting that's used in our current catalogs, and we do have a blacklight discovery layer. This is in addition to being made available for download and through a query interface for users who want to use the data in other ways. In this still shot, I think it is easier to see that the text of the inscription displays along with bibliographic information, and that the tagged entities are highlighted and associated with their VIAF identifiers. In this interface, clicking on the names opens their VIAF web page. In an interface that was developed for actual use by users, the highlighted names could be used to return all inscriptions relating to that person, or publications written by that person, or it could link to Wikipedia pages or other external sources relevant to the person. The point is the data has been made machine actionable. At this point in our project, we have a data set stored in RDF in a triple store. We've experimented with several free triple stores, including Sesame, BlazeGraph, and Forstore. For this project, we settled on Jenna Fuseki for its ease of use and performance. Bibframe and annotations can be easily uploaded through the interface. So the data set I'll be using consists of Bibframe encoded data for standard bibliographic information and open annotation encoded data for the annotations. Our triple store has the query endpoint, so it's time to SPARQL. This is where it gets fun. SPARQL stands for SPARQL Protocol and RDF Query Language, and it lets us query an RDF data store just as SQL allows us to query relational databases. There is a learning curve to getting started with SPARQL syntax, and you do need to understand the data and the data model to write effective queries. Viewing some examples of the data in a graph format, like the GraphViz representation shown during the video, something like that can be helpful for tracing pathways. Okay. So I'm going to start here with a query against our data store. This query will return a deduplicated list of all of the people in the data set, along with their VIAF identifiers. I'm actually limiting my results right now to just the first 25, strictly for speed's sake. Note that this query is going to return not just the dedicators, but all of the people. One of the identifiers in this full list, for instance, I discovered is for Stalin. This was a good illustration for us when we started querying the data about the shortcomings of our data model. Let me go ahead and run the query. And I'll scroll down here and we can see our results. So now that we have this list, we can expand our knowledge about these people by using the VIAF identifiers to gather additional data from other data sources. In order to investigate one of our research questions, Derrida's connections with international scholars, I can find more information about the people who sent Derrida presentation copies by feeding my list of VIAF identifiers through another linked data source. To demonstrate, I'm going to take one of these IDs from this result list, and I'm going to run a query against Wikidata. Wikidata is a central store of structured data from Wikipedia and related resources. It's a really nice resource to use when starting to learn SPARQL for several reasons. Wikidata is an enormous data store, and there are lists of available properties with their identifiers that are easy to find on the web, and they make it easy to navigate and build queries. But best of all, really, is this Wikidata query service. It has some fantastic tools. In addition to a collection of sample queries, which are useful for getting started, which you can find in this examples link, it also has this query building tool on the left-hand side of the screen. You can use this web form to build an entire query if you want, or you can use here on the right-hand side, you can use regular SPARQL to build your query, or you can use a hybrid approach using the form to help you structure your SPARQL query. This particular query here, I've taken one of the VIAF IDs from my list, and I'm asking it to give me the person's birth and death dates and places, excuse me, and their occupation. Let me go ahead and run that. And here's my result. In this case, I have 2 lines, even though I'm looking at one person, because the person has more than one identifier. I'm sorry, more than one occupation. To run my whole list of VIAF identifiers against Wikidata or another source to gather this type of additional information, I could use a Python script. In the context of a library catalog, expanding my list of people further, I might want to do something like generate bibliographies of the works by people who sent Derrida material, or I could discover what other publications by these people exist in Derrida's library which weren't presentation copies, perhaps indicating more Derrida's own interest in those people. And one more query. This query against our data set is going to look at how the dedicators referred to Derrida. And this query is designed to count how many times each form of address was used. This could be another way to gauge the level of personal connection between the dedicator and Derrida. Let me go ahead and run this one. And here are results. The dedicators overwhelmingly referred to Derrida using his forename and surname, with a fair number, 77 there, calling him by his first name alone. One person called him Jackie, and further down in the list is someone who misspelled his surname. This wasn't a transcription error. There were some people who misspelled his name, making you wonder how well they were really acquainted with Jacques. I have some slides here just in case I had technical problems. So now, what have we gained? What can we do with our data now that we have it, that we couldn't easily do with textual notes and MARC records? So we've made the data available in a more structured format, and we've allowed reuse by providing a SPARQL endpoint. I want to go back and start taking a look at some of the research questions that were posed in the beginning, because we can already provide some answers. From our preliminary interface, you could look for one of our research questions which related to the books on Judaism, as that wasn't a research area that Derrida was known for. Here's an example. Using this interface, we've searched and we found a book about Jews in Portugal. We can see that it was sent by Yusuf. A user could investigate Yusuf in more detail because that VIAF identifier link is provided. In addition to using an interface that we just looked at on the previous slide, we could also search for books on Judaism. Using the interface, we could search for books on Judaism and then look at the names in the inscriptions. But we could also use a SPARQL query to find a list of those names and VIAF identifiers kind of in one fell swoop. The interface results allow a human to read the name. The SPARQL endpoint allows a human to harvest the data and use it as a starting point for combining with other data. What sort of picture would emerge if these names were combined with the form in which they addressed Derrida, how they signed themselves, whether they also mentioned Derrida's wife or children, were they a family friend, listing their occupations and places of birth and residence. On the bottom of the slide there, this was a simpler query. I was easily able to pull out the number of dedications in different languages. As for lessons learned from the project, the first shouldn't be any surprise to anyone. The data needs some cleanup. Data always needs cleanup. Now that we've begun querying the data, we're discovering areas where the model helps or hinders us from getting efficiently to the data that we want. There were a lot of different skills needed to pursue this project. Among other things, we needed conceptual understanding of bibliographic data, data modeling, ontology design, RDF structure, technical skills to create and run scripts and design our annotation editor, big picture awareness, knowledge of what's going on elsewhere in the field, SPARQL query building, and project management. With so many new areas of expertise, a great deal of it technical in nature, having access to the LD4P group of highly talented people working in the same space was extremely helpful. To really begin to transform cataloging, we need to have stable tools for entering, editing, connecting, storing, and reusing our data. While there are some tools and some software which could be developed into these tools, there isn't an open, off-the-shelf type of solution for any of these pieces yet, which means that technical skills and creativity and the ability to work with the raw data remain critical at this stage. There are several vendors working in this space, Zafira, Castellini, and Ex Libris prominent among the ones that I'm aware of. Now that we have a data set, we are just starting to really understand the implications of our chosen models. In addition to new tools for creating, editing, and storing data, working in this kind of shifting landscape with partners at other institutions, we found that communication tools like Slack, GitHub, and Zoom were also essential for us. It is clear that beyond the inter-institutional collaboration that LD4P provided, we need to seek more intra-institutional collaboration within Princeton to progress further. We need greater systems involvement locally, input from patron-facing staff on what services would be worth pursuing, and input from rare books on unique material whose research value would be enhanced by providing more structured data. Two final notes. First, it didn't take 2 years for us to create our data set. We could have had a data set in a few months if we had been focused just on creating the data. Understanding the larger environment we were trying to join took more time. Second, the most useful activity was probably adding the identifiers. Distinguishing one person from another and determining their role in relation to the work were the most time-consuming activities, along with the actual transcription of the dedications. Some big questions remain and won't be easily answered. The biggie is really, is it worth it? How can we identify and measure the benefits against the effort required? In addition to traditional cataloging data, we invested somewhere in the neighborhood of 150 hours transcribing, reconciling, and tagging the inscriptions. Are there efficiencies we might gain in tools for creating and editing Bibframe that would allow us to shift more of our time to providing new kinds of data like annotations? Another big question area is storing our data in RDF the only path to allowing the kind of data reuse and customized searching that we think RDF and Bibframe can provide? Unfortunately, the way this project unfolded, we weren't able to judge what we might get out of natively created Bibframe versus Bibframe created from MARC. This would be a really worthwhile area of investigation as we continue looking at linked data. That is the end of my presentation. I thank you all very much. And Matt is going to now handle questions. Thank you.
Wow, thank you, Joyce. That was a lot of very great information. We've already got some questions, and I encourage all of you to submit additional questions and comments using the question box. The first question we've received is, why did you make the choice to leave out the publication data and the extent fields is also left out of the display?
So the interface that was shown here is very, very preliminary. Like I mentioned, we weren't intending to provide an interface, but you just can't stop Peter. He saw SparkLight and thought he would see what he could do. So that was not at all a completed system. We would obviously, in something to present to users, we would obviously be developing it so that it would contain more of the usual data and more facets.
Great. Do we have any more questions from the audience? I don't see any more coming in. If you have any more questions, please enter them in the question box. Otherwise, yes?
I suspect, as usual, when I've presented, I've stunned the audience into silence.
There was a lot to take in, and I really enjoyed it. So it looks like no more questions. So let me. I'm getting some thanks from people.
If anyone would like to discuss our project more at a later date, please feel free to contact me or a member of my team.
Great. Well, I will. Well, we're really glad you could be with us today. You'll soon receive a short online evaluation form. Oh, look at that. I just started getting a bunch of questions in. Is annotations also, can the annotations also be seen in your local catalog?
No, at this point, all of the data for our project is in a triple store. It's not available through our catalog. The dealer did provide the text of some of the annotations, and those are in the finding aid that covers the material. We have not yet incorporated the carefully transcribed and reconciled annotations back into the finding aid, but that's something we will want to do.
And the next one, is the code for the annotations editor available?
That is part of the code set that we intend to make public by the end of June.
Great, great. And then another question that came in, we will be sharing the slides. They'll be sent out just after the presentation. One more just came in. As a public library cataloger, would we be responsible for inputting and providing VIAF data? In other words, how will we learn of all this?
Well, that's a little bit tricky, and part of this, I think, comes down to the types of tools that we need to be able to work in Bibframe and with linked data. Ideally, we will have a tool where we can search for something like, you know, Shakespeare, and it will pop up some suggestions from an authority file because it's linked, for instance, to the NAF. And a cataloger would be working strictly with the text strings. So we could look at the text strings and select the one that we want. And what the editor tool will be doing is storing the VIAF identifier kind of behind the scenes. That's where I mentioned sort of we don't have really good tools. There's a number of things kind of coming along, but we need those tools that have those shortcuts that will make this easy work for us to do, where we don't have to deal with all of the coding.
And somebody just posted a URL that the annotated editor code is available at GitHub paulcam/annotation_editor. So we could send that link out as well when we send out the slides.
I'm assuming that's Peter Green out there who did that.
Yes, it was. Yes, it just came through. Does anyone else have any more questions? One more. Alrighty then. Well, we're really glad you could be with us today. You will soon receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable and help the ALCTS Continuing Education Committee plan for future events. Thanks to Joseph Oliveres and Wanda Jazzieri of the ALCTS Continuing Education Committee, and to Lee Cooley of the ALCTS Office for Technical Support. The support they provide makes it possible for us to present these webinars smoothly. We have 4 more webinars coming up in the From MARC to Bibframe series, the next one of which is March 28th's Performed Music and Bibframe, followed by one on ArtFrame. We also offer web courses, which are 4 to 6 weeks long, and e-forums, which are 2-day email discussions. You'll find more information on the ALCTS website. We hope you'll participate in other ALCTS continuing education offerings again in the future. This concludes our session. Thank you for joining us.